everybody. Thanks for joining us today for talking about graph artifacts and operator. I'm a staff software engineer here at Apollo, and I've been here for about 2 years.
And hi, I'm Jonathan. I am also a staff software engineer. I've been here since May of last year, so about getting on for 18 months, towards 2 years now as well. And we're really excited to show you some of the cool stuff that we've been building, a way of combining together the operator that you might have seen in the keynote with the new power of graph artifacts to bring really repeatable Supergraph builds and repeatable Supergraph deployments as a result.
Yeah, we're bringing you all of this because we know that you all have operated large graphs in production, and we know that managing schema deployments at scale is hard.
So first we're going to cover graph artifacts kind of in isolation, so we'll learn about what those are. I'll then go through a bit more about the operator, a little bit more in depth than I did in the keynotes. And then following that, we're going to have a look at the reference architecture that we're now proposing based on those two things. So we'll see how they fit together in order to make the experience of using Apollo so much more dependable when running in a production context.
All right, let's get started with graph artifacts. So I'm sure everybody in this room has been here. You're on call, your pager goes off, you check the logs, and it's showing an error that maybe started a few hours ago and is only getting worse. You're not sure which launch actually caused the regression, which launch is active right now. In fact, maybe you're looking at the logs and another hot reload is in progress. What was the launch ID before or after it reloaded? So you go to the launches page and there's quite a few publishes. You're reaching out to all of your subgraph teams trying to ask, okay, what did you guys change? What happened? You have multiple routers in the fleet. Some are showing the error, some are not. Are they not getting requests? Are they on the same schema version? And if you figure it out, you can't even roll back without having to go do a revert or wait for a publish, maybe even do checks again because you don't want to be the person who's like, you know what, I think this is going to work, and then it just makes it worse. So you're like,
I mean, I've definitely been that person in the past.
I've also done that, yeah. But this is the current challenge we have today. All right, so this happens because many routers today are just configured to auto-update to the latest schema from Uplink, and this is really convenient, especially for development workflows. But a lot of people are probably like, hey, I have hot reloading in prod. I don't know. Sometimes we have a lot of tools that help you kind of bridge that gap, but there's still a little bit of space for error. This happens because everything's non-deterministic. When you look at the launches page, that was just the intended state of the system. It's also the time of the last publish, but it's not actually when your routers picked it up. There's also a lot of state within your router, for example, ongoing requests and timeouts, and then performance impact on the router itself for when caches need to be warmed and validated for your previous schema. So that can have some impact. The last is it's just complicated, right? Other code does not hot reload, hopefully. And debugging what happened 5 minutes ago is not easy when you're not sure what was running 5 minutes ago. All right, so we're going to introduce graph artifacts. They're immutable version schemas that are designed for stable and repeatable deployments. And you can think of them like Docker images for your Supergraph schema. And they're in public preview starting this last Monday. I've been saying in the future for so long. All right, so what they do for you is bring schema management in line with modern DevOps practices. They're versioned. So the container itself is OCI compliant, so it's probably familiar tooling, similar to how you would use Docker. You can reference a specific artifact using the Supergraph name, which gets turned into a repository name in OCI, and then the SHA-256, which represents the specific digest. They're also auditable. You can actually map your deployments to schema changes, right? Now that you have a specific digest, a specific environment variable that you're updating with the exact container that you're running, it maps one-to-one with your deployment and with the launch. This brings GraphOps in line with deploying application code. You can also separate your build from deployment. So running the router deployment is actually deploying the schema, and your publish is just creating an artifact. This way you can have many more artifacts, some that may never be deployed. I'm sure some of you guys are using flows like having PRs that create a Docker container that you can then use to test, but that doesn't mean that that Docker container was going to be deployed. We also support tagging. So you have the same flow as you used to do with publishing your subgraph, and we'll just automatically tag it with the variant that it was intended to be for. And this way you can get versioning for that variant. You can use our platform API and see all the graph artifacts that were made for that tag. They're also revertible, so all the artifacts produced by launches are referenceable individually, and you can fetch and roll back any specific artifact. All right, so how do these actually work and how would you get started? From your perspective as a developer or a Supergraph operator, nothing changes about how you publish your subgraphs. We receive your schema update and we put it into a ordered distributed queuing system that makes sure that, if you're doing multiple publishes, et cetera, we still have the same order. And it launches a build workflow that outputs a graph artifact that we then store in our registry. And then you can just fetch the SHA-256 associated with that. And you can use that to configure your router. So instead of pointing at the old Apollo GraphRef environment variable, you can now set Apollo Graph Artifact Reference. In order to get these, there's all of this new APIs in our platform that let you take, for example, a supergraph and a variant and get your repository ID and your tag. And for example, for a specific repository and tag, get the most recent digest, or for example, get the digest itself. This is really similar to OCI, so hopefully very familiar. All of this is available starting with router 2.7, and this router knows how to fetch and unpack graph artifacts. It also supports pinning. It supports rollback without publish. You also get audit logs for your schema version, so you can say okay, when it downloads the graph artifact, when did it do it? What schema version are you on? But the real unlock here is all the workflows that you can now do, and you guys are probably familiar with just all the deployment workflows you get with any container-based architecture. So we get all the phased deployments, right? You can do blue-green, A/B, canary. So if you want to say, okay, I have multiple Docker containers with multiple SHAs that you know about, or for example, a tag that's blue and a tag that's green. You can use that to control your router fleet at a more granular level. There's also one box, for example, where you might have a deployment workflow that deploys to a single box and takes only a portion of your prod traffic. A lot of people also like to pair this with observability. So you could do something like a one box that has an automatic timer that has a bake time, for example, and you say, okay, I did this deployment. I'm going to wait 2 hours. If any of these listed alarms go off, it'll auto roll back to the previous artifact version. There's also another unlock here, which is that right now, when you deploy to, or when you publish to a variant, you're kind of doing two things, right? You're kind of publishing to almost a feature branch, but you're also deploying to a specific environment, right? They kind of combine the two. So if you wanted to take something from one variant and deploy it somewhere else, you kind of have to build it back up again, or potentially try to download the Supergraph schema and copy it over. So with this, even though you publish the container to a specific variant, it's available everywhere. So you can take that same artifact and use it to create a development environment. I know a lot of people want to be able to test changes locally, and it's obviously difficult to test a subgraph in isolation because they don't run in isolation, right? So what you can do is you can create a new development router and then just say, okay, I want to take the prod artifact that is live right now and deploy it to this router and maybe override all the URLs with staging. And then for the one you're testing, you run it locally or whatever. And now you have an isolated test environment. You can also split the cadence. A lot of people want to make sure that they are deploying only at certain times of the day, or for example, once certain criteria has passed. So you could, instead of having to coordinate this with all of your subgraph teams, just have them publish on their own cadence and deploy only once you're ready. Deployment windows allow changes to continue stacking until your deployment time is reached. And at that point, you just take whatever graph artifact you want to deploy. Is it the most recent? Do you want to take a stable one that you decided passed some subset of criteria? All right, so that was a lot of information. We're going to hop over into a demo that illustrates only one of the workflows we discussed, and a simple one because we have not that much time here today, but we're here for questions after. So if any of you guys have done the router quick start, these are the same subgraphs that the router quick start uses. So what we're going to go through is just publishing. These are already deployed. We're just going to publish these to a new Supergraph variant and show how you would deploy your router using graph artifacts. So let's do that really quick. All right. I'm copying these for the same reason. My hands are a little sweaty. All right. So we're publishing our first one. We'll take a look. And thankfully, it's here. All right, here's a new variant. And we'll take a look at the launches page. And we see that there is a new graph artifact build that's associated with the launch page. Right here, we can see that there's a fully qualified SHA-256 digest. If I copy this and just show you guys what it looks like. So you can see here the Summit demo test dash beginning SHA is the Supergraph that we were targeting, and then the SHA-256 is after, and Artifact API Apollo GraphQL is the new API that kind of replaces uplink in this situation. All right, so we're just going to publish the rest of the subgraphs really quick, and we're not going to really look at the progression because we know what they are doing. But this basically creates a supergraph that has reviews, users, products, pretty self-explanatory. All right. So let's go back to the launch page, and we should see that all of them have initiated. All right. So let's take a look at what we've built. So what we're going to do is we're going to run the router locally. And this time, the router YAML here just contains the port that we're listening on. All right. Cool. So we're here, we're looking at our schema. Let's just make a random query about ourselves. So we'll say we want to say what our name is, and then what reviews, maybe what product names we reviewed, and let's run this query. So you can see that my name is Ada, and I have reviewed 2 products. All right, so here's what we're going to do next. We're going to go back to the review subgraph, and we're going to update the schema to include 2 new fields, which is what time it was updated and the star rating. So this is going to do that. We'll go back to the launches page, and we see that there's a new artifact. We can also take a look and see that, in fact, we did add a stars and date field. So we go back here, and this is schema pulling, right? So there is no change here. We go back to reviews, and we see that nothing has changed. So that's because our router is pinned, right? We've pinned it to the previous thing. So that is the first part of what Graph Artifacts would have done for you. Next, we'll go ahead and we'll just restart the router with the new Graph Artifact schema. All right. So now we should see that there is an update, there's stars in our review. So we go ahead and add stars because we want to see what we've just done. And of course it doesn't work. And the reason is we never did any update of our subgraph. Obviously very simple, this does happen, potentially in more complex ways than this. But this is where I would have to go redo a publish. And in this case, or if I had CI/CD or whatever, I wouldn't really have to go back and do this, but I just go back and rerun the router at the previous revision. And we just wait a minute, or maybe 30 seconds, hopefully faster than that. And stars is now invalid. So we've already rolled back quite quickly. All right, so that's an example of what I could do, and in the right workflows would be really helpful. Let's go back to the slides. Okay, so now that everybody is so excited to use Graph Artifacts, you're probably wondering what else is on the roadmap. So we're also using Graph Artifacts ourselves internally, so we're as excited as you. to try all these out.
Maybe even more.
Maybe even more, yeah. I really am so excited. So this is all in public preview today, but we're going to be adding more functionality. So if you're already on Graph Artifacts, you'll get the access to add more Apollo managed resources. For example, persisted queries and operations collections are also very specific to the schema that they're deployed with. So they should be able to be modified, changed, edited, all your CRUD operations for Graph Artifacts managing other Apollo resources. We're also going to add the ability to add custom tags. So right now, as I mentioned before, only the variant name is tagged by default, but you can create and tag your own artifacts in the future. This could let you do things like, okay, I have a development tag that I use that's just for me. Or I have a QA tag that tells QA, like, okay, just have your router point at the QA tag, and that's currently what's under test. The other thing we're going to be adding is tag-based artifact hot reloading. I know some people still want hot reloading, and so for those of you who do want it, and for development workflows, right, where that thing is really helpful, and we just did schema pulling right now, you can basically point at any tag. You would change your graph artifact reference to just use the supergraph, and then : tag as you would with an OCI registry, and it'll automatically hot reload the most recent artifact available for that tag. We'll also be adding Rover CLI support for all of this. We've already exposed a decent amount through our platform API, but Rover will be adding a bunch more commands to help you add and manage your graph artifacts. Okay, so you're probably wondering, how will I manage graph artifacts, right? I don't think that we copy around SHA-256 digests, nor do we probably open the launches page to copy them out. So let's just zoom out for a second. All of this, as I said before, is available in the platform API. It can be accessed programmatically. And it's really powerful, but it needs wiring for promotions and a lot of manual integrations. And to be clear, this can work by itself or with any other container-based solution. For example, Argo CD is what we're currently using. But it also pairs with our Apollo managed declarative operator for Kubernetes resource management, which is...
What an introduction.
Exactly, a lot of buzzwords. The operator is just aware of all of your state, and it can integrate with Graph Artifacts to do this update that we just did for you automatically. So I'm going to pass it over to Jonathan to talk about the operator.
Cool. Thank you, Simone.
Thank you.
So building on top of Graph Artifacts, the operator has been using them by default for a long time. And so as a result of that, it benefits from all of the increased resilience and all of the extra things that Graph Artifacts bring, but with its own flavor that helps it run in Kubernetes. So I'm going to go through a couple of the kind of features of the operator, but really starting from the baseline of what it is in more detail than we might have perhaps gone into before. So the Kubernetes operator pattern is something that's existed for a long time, and this is this sort of canonical description of what that really is. And what it really comes down to, or the way it's been described to me in the kind of most effective way, is that the operator is like having a skilled SRE in your cluster. That's the kind of concept you're thinking about. So somebody who knows how best to operate a piece of software, and who knows how to manage the resources of that software through their entire life cycle. So how to best maintain them, run kind of simple actions against them in a way that a skilled human operator will be able to do. And so that's the idea behind the Kubernetes operator that we have, is that we're trying to build something that allows us to manage GraphOS artifacts as though they were Kubernetes artifacts, like that skilled SRE in the cluster. So, but the question is, well, kind of what is there to operate, though? If you think about it quite simply, and we think about kind of what we have at the moment inside of GraphOS, we have subgraphs and we have supergraphs. But as soon as you start to apply any sort of critical analysis to this, that kind of breaks down, and we all know that reality is way more complicated than that, because it's not just because the subgraph isn't just a subgraph schema. It's a schema and an associated service that actually provides the resolvers. And the same with the supergraph. It's as well a schema, but also a runtime which provides the ability for queries to be run against that schema. So you've got to manage all of these different parts and pieces, and that's what the operator allows. Because there are so many potential issues. How do you keep schema in sync between your server and your schema itself? How do you track schema update failures? How do you roll back? What do you do if things don't compose properly? Where do errors go? And how do you match what your router is expecting with what the server actually supports. There's so many different integration points and places where you've got to keep things in sync that managing this whole thing is so challenging. And so what if you could do all that? What if you could do all that? What if you could keep implementations in sync? What if you could track subgraphs that are deployed? Integrations with standard tools? And what about like safe deployments as well, just to throw that in there as an extra thing that we know is super easy? Like, what if we could do that? Well, the operator can, because of the way it's constructed and the way that Kubernetes works. So this diagram replaces the one we saw previously with custom resources that represent those concepts that we just saw in the diagram before. So this is the way that operators work. They essentially consist of a set of control loops and a set of resources that those control loops reconcile. And so what we have done is to invent these different custom resources and also utilizing Kubernetes deployments, the existing resource, to allow the operator to be able to solve a lot of the challenges that we saw in the previous slide. So by way of example, by utilizing a Kubernetes deployment and also the subgraph CRD, you can store your schema and server inside of the same OCI artifact, and then you don't have any issues with keeping things synced together. In addition, you can also do rollbacks by default because the Kubernetes deployments give you that for free. But also we're looking at Argo rollout integrations in the future. So at the moment we do safe deployments via kind of immutable router deploys. But in the future, we're looking at supporting blue-green deployments via metrics, maybe even metrics that come out of insights in GraphOS. So you think about how you could power deployments not only by looking at the metrics that Kubernetes gives you naturally, which are kind of very generic for kind of web services, but actually based on specific GraphQL metrics as well, which is really powerful. You can use Kubernetes status and events to track composition failures, which is powerful for the operator, but also, because of the way Kubernetes works, you can actually read those statuses and other tools can react to changes in them. So if you're building operators yourself, the operator just fits right in and you can also react to those same statuses. Or even if you're building tools that are just reading the state of the cluster and reacting. So it's not only good for the operator, but it's also good for any other tool that wants to integrate. And finally, you get this kind of end-to-end awareness of the operator. As I said, the whole point of it is that you've got this kind of embedded SRE inside of your cluster. But the operator has an awareness of your fleet of routers that has never really been possible before, because in every other time they've been deployed in Kubernetes, they all exist as their own kind of independent binaries that are running. There's no sense of a fleet. There's no sense of a kind of combination effect. But with the operator, it can conceive of the fleet as a single object, and therefore it doesn't have to think about how it manages individual pieces of that. It more thinks about how it manages the whole. But what we've talked about is a really simple scenario, where where the operator conceives of kind of everything in a single cluster. You've got users triggering composition based on what's there, and you might not, and perhaps maybe you don't care about exactly when schema artifacts get deployed, because that's kind of how uplink works. You just kind of take the updates when they arrive. And so, what if you want more than that? What if you want more control? What if you have multiple Kubernetes clusters? Or what if all your subgraphs don't actually run in Kubernetes? You run some of them in Cloud Run, some in Lambda, some on Nomad. I don't know why you would, but you could. There are many options. Or what if you have to use Rover or the platform API for some reason? Or what if you need fine-grained control over when deployments actually happen? Well, we've kind of come up with these different ideas about the Kubernetes reference architecture for Apollo. These are the ideas about how we want people to think about deploying the router inside of Kubernetes when they can. So we have this kind of idea of a single cluster deployment. So you've got all of your subgraph resources are inside the cluster. You've got a supergraph schema, which then determines which of those subgraphs actually end up in the supergraph. And then the supergraph itself, which is actually determining the size of the router fleet and how the router fleet operates. Now, what's important to point out here is that even though all of those subgraphs look like they're in Kubernetes, that doesn't actually matter. Those are just objects that represent the subgraphs. They're not the actual services themselves. And that's very deliberate, because we really want people to be able to gain value from this, even if their organization's not entirely moved onto Kubernetes. So even though you're seeing the word subgraph there, think of that as just a pointer to the subgraph itself, not the actual service. And so, but also this works with multi-cluster. So what you could also have is a situation where and this is particularly interesting if you're thinking about adopting the operator from a point of view in a sort of piecemeal process, because what you can do is you can add some subgraphs into your cluster, but others of them might be done with subgraph publish for a long time, especially if you've got multiple teams publishing these things. And so what you can do is you can set the operator up in a particular mode such that it doesn't try and think that it is the authoritative source of subgraphs. And so what that means is you can continue to have this kind of mixed economy until you get to a point where you might want to bring everything into Kubernetes kind of later on in time. And so that's, again, it's really powerful for for a kind of multi-cluster deployment anyway, but if you also want to adopt it piecemeal, you want to bring in small parts of the operator first, and then you want to move forward. A particular interesting pattern that we've seen is that some people want to just run the operator just so that it runs their fleet of routers. They want to deal with all the Supergraph publishing stuff separately, and they just want it to run a fleet of routers. And that's fine. It's still delivering value because it's still giving you a lot of the benefits of managing your routers as a fleet, but you can deal with everything else separately and you can adopt more of it later. The whole point of the operator is it's supposed to be modular, and it's supposed to have components that you can add on as you go, and that's really the kind of the power of it. So what's also kind of coming up on the roadmap for the operator? Well, we've got to GA at this point. It's 1.0, so you can go and use it in production, and we have to support it for our sins, but we're currently working on safe deployment. So this is what I was mentioning before. At the moment, we have access to the mechanisms and idioms of Kubernetes deployments, which include things like recreate strategies and all that kind of thing. But what we're trying to work out now is how we can integrate with stuff like Argo rollouts, so you can specify exactly how you want the rollout to occur. And with that, we'll get support for canaries at the level of supergraphs, and also potentially for blue-green deployments too, all powered by the operator. And then looking forward into kind of Q1 and beyond, a big feature that we've heard many customers are looking for is ephemeral supergraph development. So this is something whereby you would be able to kind of do the thing that Saman was talking about. With the operator, you'd be able to say, hey, I want to have this, something that looks a bit like this supergraph, but with this subgraph overwritten in some way. And that would all be powered by the operator, and it would be a thing that would exist, and it would tear it down and manage it for you. So you haven't got to do a lot of the things people have to do nowadays with their own systems to manage all of this stuff. And that's something that we're looking to implement, as I say, in kind of Q1 and moving forward. And I mean, there's lots of potential for that idea as well in terms of how we might integrate that with the rest of GraphOS, though I'll leave that to your imagination as to how that might work in the short term. So now we're going to try a live demo from my end. So because I'm a complete masochist and decided that, it wasn't just enough fun to have it running on my laptop, I thought, why not deploy a real cluster? So can we, yes, here we go. Right, so as you might notice from the cluster and the user at the top there, this is actually running in GCP right now. This is a publicly addressable cluster. This is a legit thing. So, this isn't just running on my laptop locally. This is actually a real legit thing. So what I want to show you is two things. So I want to show you the ability to do rollbacks without very similar to what Saman did, but without actually having to run your own republish, to show how that works. And then I want to show you something that is really exciting, which is the ability to scale in the face of an outage from Apollo. Because one of the big problems with uplink, as well probably many of you are aware, is that if you end up in a situation where uplink's inaccessible and you want to boot up a new router, unless you're using static schema, you don't have any way of getting your schema from uplink. So you can't scale. But with Graph Artifacts, that's now not a problem anymore, because the operator actually tracks the Graph Artifact reference on the deployment that it's using. So as long as you've got at least one router that's up with the schema version you need, you can scale in the face of an outage. I'm going to show you that. So let us begin. So we have all this tracked in an environment config repository. So first thing to look at for the rollback, we'll do something very similar to what Saman was doing. So at the moment, we're running this launch here, this ACCF launch. So if we want to roll back, then all we have to do is take the launch ID from here, and I can highlight it. And then we can change our supergraph resource here. We can give it a new launch ID. And then again, if we just commit to main, because security, can go sod it in my opinion. But no, I love security. They're great people. But I mean, they're for demos, So if we do that and push that to main, now Argo is sitting there and is reconciling the cluster constantly. So as you can see, that's now launching new router pods to account for the change in the launch ID that we just made. So with this, you have the ability to be able to actually move the schema version that the fleet is running to any launch ID that you like at any point. And so that doesn't just mean that you can do rollbacks. It also means that you can do exciting things like you can say, oh, we publish, we have 300 subgraphs and we all publish them at a rate of 50 a day or something. Then what you can actually say is we're only going to move on the supergraph at particular times. All of those publishes will still happen, all the compositions will still happen, but you only redeploy the router fleet at specific intervals. So that's much better from the perspective of not having to worry about how the cadence of you actually publishing those schema changes affects the actual running thing in production itself. So that's one part of it. Now, the next part, what we're doing in the cluster right now is we're simulating an outage. So this is for any of you who are complete nerds, possibly like me, you may well notice that those IP addresses at the bottom are actually the IP addresses of the uplink service that we have. So what this network policy is doing is it's actually blocking all traffic from our pods out to uplink, so they can't contact it. In fact, if I try and do that via a debug command, we'll see this in a moment. kubectl, hold on. kubectl debug. Actually, no, hold on. Get the pod name first, because this is what we do. Here we are. So what I'm going to do is I'm going to deploy a container inside of the are you sure? Oh, yeah, of course, yeah, sorry. So what I'm going to do is deploy a debug container inside of this pod, which is just running Ubuntu. And then if I install, actually no, update and get install JQ and curl. So if I install some debugging tools, then what I'm going to show you is that I can actually run a command inside of here that will prove that we can't actually hit anything uplink related. So just let that install. God, curl has so many dependencies. Jesus, I don't know. I'm always surprised. Right, I'll just leave that running while I go and grab the script I need. And just give me 1 moment. Experiments. Here we are. Since I have to store my queries inside of text files because I have no way of remembering how to structure this thing. So this is here we are. So this is the kind of query that we would send to uplink, generally speaking. So this is the kind of thing that you send to uplink. It's a GraphQL request, and it will get back the router config that you need. But if we run that, what we'll see is that this will time out in 5 seconds' time. So it won't actually be able to contact it. There you go. So we're simulating the outage. You can see I'm not pretending this is an outage. This is legit.
Yeah.
So now, if we jump back into Kubernetes, if I now go to our supergraph, or actually, in fact, if I do it inside of here, so what I can now do is if I change this replica's number to 10, then if we were running this under uplink, what would then happen is the pods would start to spin up and then they would fail. They would just die and keep going to a crash loop back off. But if we do this, and then jump back and we look at the pods, and we give it a couple of seconds, this is always the nerve-wracking part where you're like, is it actually going to make the difference or not? But we'll see. So, and there we go. And as you can see, pods are already coming up and already running. So we can scale, even in the face of an outage where uplink is inaccessible. And this is a huge deal. This brings so many new abilities to our stack and is so much more resilient than anything we've had before. And all of this is powered by the operator and its ability to be able to track graph artifacts. This is the real power of combining those two things together in order to achieve something. And as you can see, this is actually something that really works. Can we go back to the slides? So that was our demo of kind of doing live rollbacks and also of scaling in the face of outages. And so over the course of this presentation, we've covered graph artifacts and the abilities that they bring with them. We've also covered the operator and what it is, and then I've shown how they can work together in a new reference architecture to enable really resilient Apollo deployments from GraphOS. So this is kind of the content we've done at this point. I'll hand back to Jesse who's going to explain kind of how the rest is going to work. And we're going to hang around for a while. So if you want to come ask us questions, please come down the front and have a chat. But thank you so much. You've been a wonderful audience.
Thank you so much.